Imagine you are standing in front of a mirror. You raise your right hand, and your reflection raises its left. Every movement has a twin. Every action has an equal and opposite reaction. This is the symmetry of our world. But what if this symmetry extends to the deepest, darkest corners of the universe? For decades, we have been obsessed with the predators of space, black holes, objects so heavy and so hungry that even light cannot escape their grasp. But Einstein's math, the very equations that told us black holes must exist, hinted at something else. A twin, a ghost, something that does the exact opposite of a black hole. Welcome to the mystery of the white hole. Today, we are going to follow the life of a single star named Astra to see how the universe might be hiding a fountain of creation inside a mouth of destruction. Meet Astra. She is a blue supergiant, 20 times the mass of our sun. For 10 billion years, she has fought a war against herself. Her internal nuclear fire pushes outward, while her massive gravity pulls inward. But today, the fire goes out. Astra has run out of fuel. Without that outward pressure, gravity takes over. In a fraction of a second, Astra's core collapses. Imagine a million Earths being crushed into the size of a marble. This is the birth of a black hole. Einstein's equations tell us that Astra has now warped the very fabric of space and time. She has become a no-exit sign in the universe. Anything that crosses her event horizon is gone forever. For nearly a century, scientists thought this was the end of the story. Einstein himself didn't believe his own math at first. It wasn't until the 1980s that the world truly accepted them, and not until 2019 that we finally saw one with our own eyes. But let's look back at those equations. Mathematics is a curious thing. It doesn't care about the direction of time. If you film a glass falling and shattering, and then play it in reverse, the math describing the movement of the shards is still correct, even if the event seems impossible. When physicists played the film of a black hole in reverse, they found a white hole. While a black hole is a region of space you can enter but never leave, a white hole is a region you can leave but never enter. It is an eternal fountain. Imagine a traveler named Leo. If Leo falls into Astra, he is pulled in. But if Leo tries to fly into a white hole, the very fabric of space-time would push him back out. No matter how powerful his engines, he can never get inside. If the math says they can exist, why haven't we found one? This is where the second law of thermodynamics comes in. The universe loves chaos. This is called entropy. A glass breaks easily, increasing chaos, but it never spontaneously puts itself back together. A white hole is like that shattered glass putting itself back together. It spits out energy and matter, seemingly decreasing entropy in its local area. Because of this, many scientists believe they are physically impossible, even if they are mathematically beautiful. And then there is the paradox. If a white hole only throws things out, how did those things get inside in the first place? Some theorists have a wild answer. What if Astra isn't a bottomless pit? What if she is a tunnel? This is the idea of a wormhole. In this story, the matter Astra eats in our part of the universe travels through a throat in space-time and is expelled by a white hole in a completely different part of the universe, or even a different dimension. There is also a newer idea called quantum loop gravity. It suggests that Astra doesn't collapse forever. Instead, she reaches a point where she can't be crushed any further and rebounds like a compressed spring. But because gravity slows down time, this bounce takes an unimaginable amount of time. To us, she looks like a black hole, but in the far future, she may explode into a white hole. Some scientists have even suggested that our entire universe began as a white hole. Think about the Big Bang. A sudden, massive ejection of matter and energy from a single point. It sounds familiar. We didn't believe in black holes for decades because they seemed too strange to be true. Today, white holes are the ghosts in our equations, mathematical possibilities, waiting for a discovery to bring them to life. We may never be able to enter a white hole, but by studying them, we might just find the exit door to our own universe.